Welcome to The Explainer. Okay, today we are unpacking some truly fascinating research on how we teach STEM. We're going to look at this through a very specific lens, finding meaning and inclusion in technical education. Because, understanding the math behind a renewable energy grid, that's great. But understanding how that grid impacts the real, everyday people living underneath it, that is where the magic happens. So, we're going to map out this journey using a newly published study on climate and environmental justice in technical contexts, and we'll also pull in some insights from a guide on architectures of sustainability and hybrid careers.
So I want you to imagine for a second that you're a student from an underrepresented background. You're sitting there in a highly technical, rigorous STEM class. The equations on the whiteboard are totally abstract. The data sets are pristine. But when you look out the window at your own community, you see some really pressing environmental and social issues. Maybe it's poor air quality, unequal access to green space, or the very localized impacts of climate change. And you just sit there asking yourself, how does this abstract science actually connect to the real world? Like, how does it help my community? When technical education ignores those realities, it creates a profound disconnect.
And honestly, this disconnect is incredibly common. Just 17%. According to the research, only 17% of STEM courses actually include issues related to environmental justice. That leaves a massive, glaring gap. It basically means the vast majority of technical education is operating in a complete silo, totally separated from the lived experiences of marginalized groups and the social realities of our global climate challenges.
Okay, let's dive into this. Here is our roadmap for today. First, a student's search for inclusion. Second, mapping the justice spectrum. Third, Cluster 1 versus Cluster 4. Fourth, empowering underrepresented students. And finally, engaging communities for justice.
Section 1. A student's search for inclusion.
The absolutely crucial point here is that when STEM courses ignore systemic inequalities, it creates what we can call an exclusion gap. The source research points out that for students from underrepresented backgrounds, like BIPOC or low-income communities, when their lived experiences are excluded from the curriculum, it actively harms their learning. It significantly reduces their sense of belonging, and it negatively impacts their overall participation in STEM fields. Integrating climate and environmental justice, or CEJ for short, isn't just about adding new facts to a syllabus. It's about creating a culturally responsive learning environment where students feel their world actually matters to the institution.
Moving on to Section 2. Mapping the justice spectrum.
So how do we actually measure this? Well, this conceptual framework brilliantly illustrates how the researchers tackled the issue across 11 different courses at a technical institution. Think of this as our map. At the top, they blended standard CEJ definitions with specific forms of justice. Things like participative justice, which determines who actually gets to make decisions, and epistemic justice, which is all about whose knowledge is valued. They pushed all of this through a framework for sustainability education alongside specific pedagogical approaches like experiential learning to really evaluate how deeply these technical courses integrated justice into the classroom.
Using that framework, the authors plotted the courses on this scatter plot right here. On the bottom x-axis, we have the what, meaning how much did they talk about environmental justice? And on the left y-axis, we have the how, their pedagogical practices, like using community engagement or inclusive teaching methods. Based on this, it's like a giant puzzle, and the courses fell neatly into 4 distinct clusters. As a student seeking an inclusive education, where your course lands on this graph pretty much dictates your entire experience.
Section 3. Cluster 1 versus Cluster 4.
Let's set up a stark juxtaposition to see what inclusive versus non-inclusive pedagogy actually looks like in practice. On the left, we have Cluster 1, Holistic CEJ. This is the gold standard. Here, we see what's called third-order transformational learning. Instructors are co-creating with deep, reciprocal partnerships right in the community. They're even integrating traditional ecological knowledge, or TEK. This actually transforms student beliefs and helps redistribute power. But then on the right, we have Cluster 4, which has minimal or even zero CEJ. This is just first-order learning. It's highly functional, transactional knowledge transfer. Students might build a slick tech project for a city, sure, but they never discuss the systemic environmental inequalities affecting the actual people in that city. The focus is purely technical, and it's often driven by corporate pressure.
Now, what's really interesting about this slide is the vast gap between Cluster 1 up in the top right and Cluster 4 way down in the bottom left. The solitary course in Cluster 4, which was a pure engineering and computer science class, had incredible potential for inclusion.
I mean, they were building heat sensors for bus stops in a southern Florida city. But because they completely omitted the CEJ context, like, discussing which specific neighborhoods suffer from urban heat islands due to historic redlining, they missed a massive chance to connect technology to real social outcomes for marginalized communities.
Section 4. Empowering underrepresented students.
So what does this all mean for the people in the seats? How does moving towards that top right holistic cluster actually help students? Take a quick moment to read this quote from a student in the Urban Futures course. They're questioning global power dynamics, historical responsibility, and future industrial policy. This perfectly captures what happens when you create genuinely inclusive spaces. Students from diverse sociocultural backgrounds no longer have to check their lived experiences or global perspectives at the door. They bring their critical questions directly into the classroom, and that enriches the academic environment for absolutely everyone.
And this brings us to a really beautiful concept called epistemic justice. Essentially, it means centering and prioritizing the knowledge of marginalized communities. For higher education institutions, which have historically operated with a pretty deficit-based view of outside communities, this is revolutionary. When a university validates a student's community knowledge or brings in indigenous partners to share traditional ecological knowledge, it begins to repair those historical deficits. The research tells us that this validation directly supports the academic success, the agency, and the retention of students of color in STEM fields.
Finally, Section 5, Engaging Communities for Justice. The absolute hallmark of those top-tier holistic courses is community-engaged learning. It's not just doing a project for a community, it's co-creating with them. The benefits outlined in the source material are profound. It repairs community trust. It explicitly redistributes power away from wealthy academic institutions right into the hands of marginalized groups. It forces students to really understand their own positionality and biases. And by integrating traditional ecological knowledge, students walk away with high-context, collaborative problem-solving skills that pure textbook learning simply cannot replicate.
Let's see how this actually builds into the real world. Our secondary source on architectures of sustainability maps this out beautifully. The holistic community-engaged skills learned in these inclusive courses translate directly into modern, high-impact hybrid careers. A student doesn't just graduate as a generic engineer. They become a geospatial climate engineer using satellite data for equitable resilience planning. Or maybe they become climate tech entrepreneurs building participatory interfaces with indigenous communities to visualize renewable energy siting. They're developing the exact socio-technical skills the future so desperately demands.
Okay, so how do we get there? The researchers left us with this highly practical matrix for increasing inclusion. If you look at the intersections here between administrators and instructors across the institution, the classes, and the curriculum, it gives us a blueprint. To make this shift, institutions have to actively embed justice directly into pure STEM courses. We literally can't just leave it to the humanities anymore. We need to expand community partnerships, provide real funded training for technical instructors, and, crucially, appoint leaders of community organizations as official co-instructors to truly incorporate alternative ways of knowing.
Which leaves us with this final provocative thought for today. Think about where you learn or where you work. Is the technology and science you are engaging with separated from the social realities of the people it actually affects? We've seen that moving from just having potential to being holistically inclusive requires deliberate action, deep community partnership, and a real willingness to confront systemic issues head-on. So how can your institution make that shift? It's a challenging question, for sure, but as the research clearly shows, the future of a just and sustainable world depends on us answering it. Thank you so much for exploring this with me today. Keep learning, keep questioning, and I'll see you next time on The Explainer.